When one of the equations in a system of equations is missing a letter, that's a cool deal. So that equation is missing the letter y. So I'm going to take the first and the third equations, and I'm going to force those to lose the letter y so that I will have two equations that will have just the x's and the z's. I'm even going to write this over again so that you can see that the second equation is missing the letter y. So again, this is just all of the equations written over again, but I'm going to highlight this one and call it one of my starred equations that does not have the letter y. And I'm going to go ahead and I'm going to add equations 1 and 3 together to get rid of y. So this 1y and that minus 1y. So this 1x and this 2x adds to be 3x. The y's are gone, and a negative z and a positive 2z adds to be a positive z. Be careful, a negative 3 and a positive 3 is 0. So I now have my second starred equation. So these are the two that I have to work with now to eliminate either x or z. So now I'm going to multiply equation 2. You know, you can do anything you want to any equation, so I'm going to multiply equation 2 by a negative 1 because that'll make this z become a minus z. So this x will be a minus x and then a minus z, and be careful, the 2 gets multiplied by a negative 1 and becomes a negative 2. And then this is, let's see, this is statement 1, statement 2, statement 3, here's statement 4, just to help you keep track of what I'm doing. I am now adding statements or equations 4 and 5 together. So 3x minus 1x is 2x. The z's cancel, and 0 and a negative 2 adds to be a negative 2. And when I divide both sides by 2, I get a solution for x of a negative 1. I take that answer, I'm going to highlight it. I take that answer and I put it into one of the, I either put it here for x or I put it here for x. It looks easier to put it here, so I'm going to put it into equation 2. So in equation 2, which reads x plus z equals 2, I'm going to put a negative 1 in for x, and I'm going to add 1 to both sides, and I'll find out that z is equal to 3. Now I'll go back to one of the original equations because I have an answer for x and an answer for z. It cannot be this equation because it doesn't have the letter y in it. I guess I'll go into equation 1. So equation 1 reads x plus y plus z equals a negative 3, and I know x is a negative 1. I know z is 3. Those two numbers are on the left side of the equal sign, so I'm going to combine them. A negative 1 plus 3 is 2. I'm going to, I'm looking at my notes here. I see that I copied this incorrectly. This was supposed to be a minus z, so I was kind of bothered by my answer. So minus 3 here, so I have y minus 4 on the right on the left side. And now I'm going to add 4 to both sides of the equal sign, and I'll find that y is equal to a positive 1. So the ordered triple that I have for a solution to this is a negative 1, y is a positive 1, and z is a positive 3. So remember, it's got to be in alphabetical order, x, y, z order. And then you should check those answers in all 3 of your original equations to make sure that you've completed this correctly. All right, let's look at a story. The computer system at 3 weather bureaus have a combined hard disk memory capacity of 8 terabytes. That's one sentence that's going to help us write an equation. The memory capacity of A and C have 0.2 terabytes. More memory than twice B. That's another. So let's say the combined hard disk memory of 8 terabytes. That's going to be A plus B plus C is 8 terabytes. The next sentence, the memory capacity of A and C, that must mean let's add them together, have 0.2 terabytes more than twice B. So A and C have 2/10 more memory than twice B. We'll come back and clean that up in a minute. And then finally, twice the sum of A and B is, that's where my equal sign is, twice the sum of A and B is 3 times that of C. Twice the sum of A and B is 3 times that of C. So now I'm going to run out of space, so I'm going to have to clean these up fairly quickly. I should have written them off to the left. Let's go ahead and write it over here. So we have A plus B plus C equals 8. And then see this minus, this 2 times B, I'm going to subtract 2 times B from both sides. So I'll have A minus 2B plus C equals 0.2. And then here I have 2 times A plus 2 times B. And then I'm going to subtract 3 times C from both sides. So I'll subtract 3C. So I have 2A plus 2B minus 3 times C equals nothing now. And I think what I'm going to do, I'm going to periodically erase. So hopefully you've hit pause right now if you need to write the original equations down. But I'm going to erase those and work from the right side. And let's go ahead and eliminate the letter B, because negative 2B and the positive 2B will add to be 0. So I'm going to add these statements 2 and 3 together right now. And that will be a 3A. And 1 minus 3 is a minus 2C equals 0.2. And I call that a red starred equation. Now, I've got to get rid of B again, and I've got to either use 1 and 2 or 1 and 3. I'm going to go with 1 and 2. And I'm going to multiply over here equation 1 by the number 2, so that this will become a 2B, but so will the A. It'll be a 2A, a 2B, and a 2C, and the 8 times 2 will be 16. I'm going to copy equation 2 over here. So it's A minus 2B plus, that's a 1C right there, equals 0.2. And then I'm going to add the above two statements. I'll put statements here. So add these two. So 2A and 1A is 3A. The B's cancel out. 2C and 1C is 3C. And 16 plus 0.2 is 16.2. And now I have a second red equation with A's and C's. I'm just looking at my notes to be sure this is what I got. I believe so. I think I'm going to cause maybe, oh look, they both have 3 A's in them. So what if I take this statement over here, and what if I multiply that by a negative 1? By a negative 1. So this 3A will become a minus 3A. This minus 2C will become a positive 2C. And the 0.2 will become a minus 0.2. And then I'm going to add the above two statements. So the A's cancel. 3C and 2C is 5C, and 16.2 take away 0.2 is 16. And so when you divide by 5, and because I'm talking about terabytes of disk space, I'm going to go ahead and get the decimal number for this, which is probably about 3.2, I think, for C. So once I know what C is, I'll go into one of the two red statements with the 3.2. It doesn't matter which. I guess I'll go into this one right here. So it was 3A plus 3c equals 16.2, and 3a plus 3 times 3.2, which is 9.6, I believe. And if you don't mind, I'm not going to show all the work. I'm going to subtract 9.6 from both sides. Heck, I'll go ahead and try. So I have 3a equals 6.2 and 4, 6.6, I think. And you divide by 3, and you get a is 2.2. Finally, I'm just going to tell you that when you solve for b by going into one of the original equations right here. Oh, look, actually a plus b plus c is 8. So b turns out to be 2.6 because you need all of those to add up to be 8. And these three numbers will add up to be 8. Be sure to take a, which is 2.2, and subtract 2 times b, which is 2.6, and add c, which is 3.2, and see if you get 0.2. And likewise, do this here as well. When we come back in our next segment, we're going to solve a system of equations in 3 variables using determinants. I like this algebraic method a lot. It's got a great pattern, but Kramer again found this pattern that existed and decided to create Kramer's rule for a 3 by 3.